How was uranium enriched for the WWII atomic bomb? Have you ever wondered how scientists managed to create the atomic bomb during World War II? One of the key steps was enriching uranium, a complex process that took place as part of the Manhattan Project. Natural uranium is mostly uranium-38, which cannot sustain a nuclear reaction. Only about 0.7% of it is uranium-35, the isotope needed for a bomb. The goal was to increase uranium-35 to around 90% for the bomb known as Little Boy. 3 main methods were used at different facilities in Oak Ridge, Tennessee. Each method took advantage of the different properties of uranium isotopes to separate uranium-35 from uranium-38. First, there was the liquid thermal diffusion method used at the S50 plant. This process created a temperature difference in a column filled with uranium hexafluoride gas. The gas was heated on one side and cooled on the other. The lighter uranium-35 molecules moved toward the hotter side, while the heavier uranium-30 molecules drifted toward the cooler side. This method provided a slight enrichment, raising the uranium-35 concentration to about 0.922%. It served as the first stage of enrichment. Next came the gaseous diffusion method at the K25 plant. In this process, uranium hexafluoride gas was pushed through thousands of porous barriers. Because uranium-35 is slightly lighter, it passed through the barriers faster than uranium-38. Repeating this process many times gradually increased the uranium-35 concentration to levels between 7% and 23%. This method proved to be more efficient and became the main technique as the project advanced. Finally, the electromagnetic separation method was used at the Y12 plant. This stage involved calutrons, which are large devices that ionized uranium atoms. The ions were then passed through strong magnetic fields. The magnetic field caused uranium-35 ions to follow a different path than uranium-38 ions due to their mass difference. This allowed for the physical separation and collection of highly enriched uranium. This method achieved the final enrichment of up to about 90% uranium-35, making it suitable for bomb fuel. After these processes, the enriched uranium was transported to the Los Alamos laboratory in New Mexico. There, it was assembled into the Little Boy atomic bomb, which was dropped on Hiroshima in August of 1945. This multi-step enrichment process combined the strengths of each method. Liquid thermal diffusion provided initial enrichment, gaseous diffusion increased the concentration further, and electromagnetic separation completed the process to create weapons-grade uranium. The scale and coordination of these facilities represented a major technological effort during the war. The development of nuclear weapons fundamentally changed warfare and global military strategy.